Welcome to our statistics learning session. Today we'll be talking about chi-square distribution. To do this, let's start with the building block first, which will give us the Gaussian distribution, and we'll be using Gaussian random variables to create a chi-square distribution. So let's get started. We know the Gaussian is indexed by two parameters. One is mean and one is variance. But the chi-square distribution indexed by only one parameter, which is an integer, and this parameter is called degree of freedom. now, now let there be many independent Gaussian variables which are independent, and we square them, these independent standard Gaussian variables, and we sum them. If you do that, then what we get is a distribution which is called chi-square distribution. What I'm saying is that let there be many standard normal distribution which are independent of each other, and there are many of these. There are many of these independent Gaussian distribution, and they are all around the place. And we take L2 norm, square of L2 norm of this independent Gaussian distribution, which are all over the place. Then what we get is a distribution called chi-square distribution. This is called chi-square distribution with a freedom d. Now, for sake of demonstration, let there be a two-dimensional problem where in x dimension there's a Gaussian distribution. In y dimension there's another Gaussian distribution, and we have these two values that derives from first and second Gaussian distribution, and let this be x and y. This x and y be a Gaussian vector. Two-dimensional Gaussian vector. What we do now is we take the L2 norm of this Gaussian vector, which will give us a variable x square plus y square is equal to z square This variable will be distributed according to chi-square with 2 degree of freedom. Chi-square with 2 degree of freedom. Now, this is this j square will be equal to 2 degree of freedom. Now let's move on to another problem where we need the PDF of chi-square distribution. The formula for PDF of chi-square distribution is 1, 2, k divided by 2 sigma k square k2 e x by 2, where k is a degree of freedom. Now let k be 2. Let k is equal to 2. What we get here? If k is equal to 2, then 1 minus 1, example, x by 2, 2, 1, 2 by 2 equal to x is 0. So this is 1 minus e x by 2, 2 sigma 1, which is equal to e minus x by 2, 2 sigma 1. That's what it is. Now this is a value, and this should be somewhere equal to exponential 1 by 2. Next step, what if you plot this PDF of chi-square distribution? If we do that, when the degree of freedom is 1, we'll get some kind of exponential distribution. When degree of freedom is 2, the exponential distribution will be smaller, but still exponential distribution. And when degree of freedom is 3, it is no longer exponential distribution, but somewhere there's a bump slightly at around 1, and it goes slope stuff. When degree of freedom is 4, the bump has moved slightly to the right. And when it is 5, it keeps moving to right. And on 10, the bump starts flattening out around 10. And when it's 20, it becomes even more flatter. From this, we understand that as the value or degree of freedom increases, it also increases the variance as well as the expectation of the distribution. In the end, let me quickly summarize what we learned today. We talked about chi-square distribution, how the chi-square distribution mean in first place, and how it's calculated. We talked about how to calculate a distribution of a chi-square distribution using a formula, and we saw that how the distribution PDF changes as the degree of freedom changes. That's all for today. I will see you next learning session. Thank you so much.